Our next topic is testing of statistical hypothesis. We have found that statistical inference deals with the process of making inferences regarding the parameters of a population based upon samples taken from those and also using statistical techniques. Statistical inference has mainly two branches: estimation of parameters and also testing of statistical hypothesis. In this section, we will consider test based upon various distributions like chi-square normal distribution, chi-square distribution, and also student t distribution. Actually, what is meant by a hypothesis? Hypothesis means an unproved statement. We are making a lot of statements. Of these statements which are unproved, those statements are regarded as a hypothesis. But in statistical hypothesis also we deal with certain statements, but they are regarding the various statistical measures of a population, or which are known as parameters. So statistical hypotheses are certain statements proposed regarding the parameters of a population. We have a lot of such statements regarding the parameters of a population. For example, the average consumption of water by various people in a village has a value some 25,000 million liters, or the proportion of electrified houses in a village is 0.75. The proportion of literacy in a village is 0.25, etc. So these are certain statements regarding the group of individuals coming under that investigation. And those statements regarding these parameters of the population are known as statistical hypothesis. In testing of statistical hypothesis, we are accepting or rejecting those statements. They are true or false based upon samples taken from that. Therefore, testing of statistical hypothesis is a decision-making task. We will say that the sample has sufficient evidence to accept, or we say that the data do not support the proposed statements. Therefore, testing of statistical hypothesis is the process of accepting or rejecting a hypothesis regarding the parameters of a population based upon samples taken from those population. In this connection, we have various terms to be discussed in this section. So they are the terms related to the testing of statistical hypothesis. So first we will come to null hypothesis and alternative hypothesis. The hypothesis being tested is known as null hypothesis. So for example, uh, suppose we have to test whether the proportion of electrified houses in a village is 0.45. Therefore, first of all, there must be a letter representing the proportion. We take it as P. And we denote a null hypothesis using H0, H in capitals and 0 as a suffix. That 0 stands for null. Therefore, we formulate the statement as H0 colon P equals 0.45. This is the hypothesis to be tested. So the hypothesis to be tested is taken as a null hypothesis. Now, associated to a null hypothesis, there is another hypothesis known as alternative hypothesis. So based upon the decision on this null hypothesis, we will accept or reject the alternative hypothesis. The test is always done on null hypothesis, and therefore the accepting or rejecting is regarding the null hypothesis. So when we accept a null hypothesis, we will reject another hypothesis, or when we reject a null hypothesis, when we will accept another hypothesis. This another hypothesis, this alternate hypothesis is associated to this null hypothesis. That is the hypothesis accepted or rejected according to the rejection or acceptance of null hypothesis is known as alternative hypothesis. It is denoted by H1. Therefore, in the test we cite, the test required is always cited in alternative hypothesis. We shall illustrate this with the help of an example. Suppose we have to test whether the proportion of uh, no, the average consumption of water in households of a village is greater than k. Therefore, the test required is greater than k. But in H0, we will cite a fixed value for the parameter. That is, we cite that H0 mu equals k, where mu represents the parameter population mean and k is the suspecting value of this population mean. Therefore, H0 mu equals k. It was as H1 mu greater than k. So that is the alternative hypothesis. So based upon the sample taken, when we accept H0 mu greater than mu equal to k, when we accept H0 mu equal to k, then we say that the average consumption of the data support that the average consumption of water in the water consumption of water in the village is k. Therefore, at the same time, if we reject the null hypothesis H0 mu equal to k, we will conclude that the average consumption of water is greater than k, or the data do not support that the average consumption of water is equal to k. Likewise, H0 mu equal to k, mu less than k, or H0 mu equals k, then H1 versus H1 mu not equal to k. So we fix the alternative hypothesis based upon the test required, and also in null hypothesis we will always cite a fixed value for the parameter, that is H0 mu equals k and versus H1 mu greater than k, and H0 mu equals k versus H1 mu less than k, and H0 mu equals k versus H1 mu not equal to k. So the range of the parameter cited in H1 is according to the test required. In H0, there must be a fixed value for the parameter. So that's about the null hypothesis and alternative hypothesis. Now there are two types of errors possible to commit in various test procedures. The two types of errors are known as type 1 error and type 2 error. Type 1 error is the case of rejecting a null hypothesis when H0 is true, and type 2 error is accepting a null hypothesis when H0 is false. So these are the two actions of committing errors in any test procedures, that is rejecting a null hypothesis when H0 true and accepting a null hypothesis when H0 is false. This is illustrated with the help of an example. Suppose the proportion of students who like westernized manners in a college is 0.25. So the test required is H0 P equals 0.25. But based upon a sample taken from that population, we find that uh, this proportion of students who like the westernized manners is less than 50, positively less than 50. Okay, so then therefore even when the proportion of students is 0.25, sometimes we will be directed to reject the sample, reject it as the sample indicator. Sometimes the proportion of uh, students who like westernized manners may be actually 0.25, but the sample may direct to reject the hypothesis because the evidences from sample do not support to select to choose p as 0.25. It may be some greater than some other value or less than. There is no evidence to support, there is no evidence to accept p equal to 0.25. So even though it was an actual value, we were forced to reject the hypothesis. That is a situation of rejecting a true hypothesis. At the same manner, we may be directed to accept a false hypothesis based upon the information from the sample. Therefore, the two possible types of errors are reject a true hypothesis and also accept a false hypothesis. And we know that these other on the other hand, suppose reject a false hypothesis, that's a good action, and at the same time accept a true hypothesis, that is also a good action. Therefore the errors are in the two actions of rejecting a true hypothesis and also accepting a false hypothesis. So these are the two types of errors considered in any test procedures. Next is a test statistic. So based upon a sample only, we conduct whether the hypothesis is true, we test whether the hypothesis is true or false. Therefore, again, we have to consider a function of sample values for uh, for testing the parameter or testing the null hypothesis. The function of sample values proposed to test the hypothesis is known as test statistic. So the statistic used for testing is known as test statistic. For example, if sample mean is used to test the uh, population mean has a specified value, then statistic sample mean is the test statistic. If you select sample proportion as the test statistic and sample proportion as a statistic, then the test statistic is sample proportion. Actually, we require essentially a statistic, a function of sample values to conduct the test, because we are not conducting a complete enumeration or census. Based upon the sample only, we are conducting the test. Therefore, the informational sample has to be utilized properly, or we should formulate an equation to conduct the test. And that equation formulated based upon this x variables representing sample, that is x1, x2, etc., xn, is known as test statistic. When the same statistic is used for estimating, it is known as estimator. When the statistic is used for testing, it is known as test statistic. So here we have an example for proposing a test statistic. Here we propose sample proportion as the test statistic. Next is the critical region and acceptance region. We have found earlier that test statistic will be, or statistic will be, a variable. The main feature of statistic is its variability, while a parameter is a constant. And that is the main thread of sampling distribution. Sampling distribution is the probability distribution of probability distribution of a statistic. Statistic is a variable, therefore there is a probability mechanism governing its variability, and that probability mechanism is known as sampling distribution. Anyway, statistic, or here the present term is test statistic, is a variable. So since it's a variable, it has a range of variation. It has a set of limits called lower limit and upper limit. For example, if we propose sample proportion as a test statistic, its variability is between 0 and 1. If we propose a test sample mean as a test statistic, its general range of variation will be minus infinity to plus infinity. If we propose sample variance as a test statistic, definitely its range is always greater than 0. Therefore, there is a range of variation associated with each test statistic. In critical region and acceptance region, we will divide the total range of variation of test statistic into two sections. One is the section in which we reject the hypothesis, and other is the range of test statistic in which we will accept the hypothesis. Based upon the values of sample, the value we calculate the statistics value. If the value of the statistic appears in rejection region, we will reject the hypothesis. If the value of the statistic appears in acceptance region, we will accept the hypothesis. Therefore, rejection region is critical region is meant for rejecting a true hypothesis, and rejecting hypothesis, not true hypothesis, and acceptance region is meant for accepting the hypothesis. Thus, the total range of test statistic will be divided into two sections. Here we have taken one example, 0.15 and 0.35 as we accept the hypothesis. So the complement of this section, that is 0 to 0.15 and 0.35 to 1, will be considered as the rejection region. So there may be a question, how do we set the interval for accepting, and how do we set the interval for rejecting? It is based upon certain statistical devices again. Now, so that's about critical region and acceptance region. Next is a level of significance. Level of significance is actually a probability. It is the probability of type 1 error. Type 1 error is only an action of rejecting a true hypothesis. So the probability for committing that error is termed as level of significance. So probability for rejecting H0 when H0 is true, that is known as level of significance. This action of rejecting H0 when H0 is true, that is known as type 1 error, and its probability is known as level of significance. So what is the level of significance? It is simply a probability. Probability of what? Probability of rejecting a true hypothesis. Likewise, we have another term called power of test. Power of test is also a probability. It is the probability of rejecting H0 when H1 is true. So we note that this rejecting H0 when H1 is true is a good action. So its probability is considered as power of test. At the same time, rejecting H0 when H1 is true is the complement of accepting H0 when H1 is true. Therefore, the property of probability that probability of an event is 1 minus probability of its complement. We have again power of test as 1 minus probability of accepting H0 when H1 is true. Therefore, this rejection section or the range of variation of test statistic in which we reject has been replaced by its complement range, that is accepting H0, the range of accepting H0 when H1 is true. So but accepting H0 when H1 is true is same as type 2 error. Therefore, power of test is 1 minus probability of type 2 error. We represent beta we use beta to represent type 2 error. Therefore, power of test is type 2 power of test is 1 minus probability of type 2 error, and also level of significance probability of type 1 error. Now next is one-sided and two-sided test. Earlier we found that we set the alternative hypothesis based upon the test required. For example, if the population mean is greater than certain value is to be tested, then that greater than part is cited in alternative hypothesis. What we mean is there must be a fixed value for the parameter in the null hypothesis. That is H0 mu equal to mu 0 versus H1 mu greater than mu 0. Here we consider only one side of the parameter, that is mu 0 and above. We don't suspect that this population mean will never go below mu 0. We only suspect that it is greater than mu 0. That is to one side only. That is why we say this is a one-sided test. Even this is one-sided and also right-sided test, because mu greater than mu 0 means the parameter or values of the parameter mu are in the right side of mu 0, that is H0, that is in H1. That is H1 mu greater than mu 0 is right sided test. Likewise, we have the left sided test H1 mu less than mu 0. So in one sided test we have right sided test and left sided test, and in two sided test we have H0 mu equal to mu 0 against H1 mu not equal to mu 0. Here we extend towards the left and right sides of mu 0, that is a suspecting value mu 0. Left side and right side are considered in H1, so that is a two-sided test. Therefore, the type of the test is based upon the interval of the parameter cited in H1. It may be one-sided, then right or left according to the interval in the H1, and two-sided if it is not equal to mu 0. The next is simple and composite hypothesis. It's based upon the parameters of a population. If the parameters in a hypothesis, all the parameters are completely mentioned, it is a simple hypothesis. For example, we have given that the population follow normal distribution. Then there are two parameters for normal distribution. That is, one is mean, population mean mu, and other is population standard deviation sigma. Therefore, in a hypothesis, if you address both parameters, it's a simple hypothesis. At the same time, if you miss one of the parameters, then it becomes a composite hypothesis. For example, if the population follow normal distribution and only the hypothesis is H0 mu equal to mu 0 only, then we are missing the second parameter. We are missing a particular value for the second parameter. So it is a composite hypothesis. At the same time, if h0 mu equal to mu 0 and sigma greater than sigma 0 is also a composite hypothesis because the second parameter is not specifically given in that. Therefore, a hypothesis will be simple if all the parameters of the population considered in that all the parameters of the population are specifically given. Then it is a simple hypothesis. Otherwise, the hypothesis is said to be composite. In case the population has only one parameter, then and that parameter value is completely mentioned in that hypothesis, the hypothesis will be simple. At the same time, if the population has some k parameters, values of all those k parameters must be mentioned in the statement in the hypothesis, then only it becomes simple. If any of the value of the any value of the any parameter value missing, then that will be a composite hypothesis. Missing means not, even given with a range of the parameter is also given, also considered as a composite hypothesis. Like h0 mu equal to mu 0 and sigma greater than sigma 0 is a composite hypothesis. That must be simple only if h0 mu equal to mu 0 and sigma equal to sigma 0. These are the various terms related to testing of hypothesis. Our next section is to discuss, our next aim is to discuss large sample test.